Hi, hello everyone. Welcome back to the Techers. My name is Surmeet, and I hope you're having a great time. See, last time in the last videos we have discussed how diodes can help us connect the DC powered equipments on an AC outlets. And today we're going to discuss more about how we can achieve that, and we can achieve that through rectifiers. Let's see how that works. Okay, now let's see how does a rectifier actually works. See, we are already discussing that they help us connect the DC powered equipment on an AC outlet. Now, why is DC powered equipment more important? Is because they use less power to operate. That means they have a less power consumptions, which in turn means less bills. And power reduction is currently a major topic going on in the industry. So for example, to light up to provide the same amount of light or even more, an LED bulbs consume a way less amount of power than a halogen bulb. And what actually a rectifier does is it helps convert AC power to a DC power, as shown in the graph here. This is an alternating current and this is a direct current. That's the output we get from a rectifier. Now let's see what exactly is an AC power. First, we get into what's happening inside the rectifier. In AC power, the voltage is alternating, as the name suggests, alternating current. Voltage and current, it's all alternating. So it has two halves, two cycles, which is one is a positive cycle, which means the voltage rises from 0 to its peak value, then back to 0, and then it goes into the negative cycle, which means now from 0 to the negative peak and back to 0. This is one cycle of an entire frequency, um, and this continues on. All right, and now how does a rectifier actually provides an output? See, this is what in front of us is a half wave rectifier. What in this there's only one diode in the series, and then you have your load, which is for any equipment. Now what this does is, in when we have a positive cycle in our AC power, during the positive half, well, the positive cycle, the diode is forward biased, which means now the voltage or the current or any of the power, the AC power, it passes through and goes to our load. But during the negative cycle, this diode is reverse biased, which means it will now act as an open circuit and it won't let the power go through. So you get an output like this. Whenever there's a positive, uh, wherever there is a positive cycle of the power, you get an output. When there's a negative, there's no voltage, nothing. All right, that's your half wave rectifier. Now let's see if you want to rectify the entire wave. You We have to arrange the diodes in this manner. Now I'm going to show you why does this happen. This is what we call a full wave rectifier. How does this work and how exactly it works? See, now during the positive cycle, that means the positive is here and negative is here, which means the diode, this one, as you can see, the positive is connected to the positive terminal of this diode. This is forward biased, and this diode is also forward biased because the negative is connected to the negative terminal of this diode. Rest these this is this one, and this one is reverse biased, which means these will act as an open circuit and this will be connecting our circuit. How does this happen? See, this would be the representation of of our circuit now, and all our positive cycle voltage will be passed through in this. So if we will be able to get our output from here, and we get the waveform like this. Now what happens during the negative cycle? That means our negative is here and positive is here. So since this negative terminal is connected to this diode, this will be a forward bias diode now, and this will be reverse bias, this will be reverse bias, and this will be positive bias, which is this and this diode are now in positive biased condition, forward biased condition. So now a circuit becomes like this. Again, where we wanted the output to be positive is connected to the positive cycle, and wherever we wanted a negative, it's connected to the negative cycle. So again, now our wave becomes as it's going into a positive. Even though it was a negative cycle through the source, the output we get is again a positive cycle. Now this is our full rectified waveform. Okay, this is the entire output we get. Now we can further smooth this wave using a capacitor in parallel. Now how does the capacitor work in parallel? See, when there's a positive during the positive during the peak of the cycle, when we are getting the output, the capacitor over here gets fully charged, and when the value is going down, that means it's going back to zero, the capacitor will start pushing the charge out towards the output. Now it makes it looks almost exactly like this. That's how we get the smooth wave. That's how the capacitor works, and they help us reduce the noise or smoothing of any signal or any wave. That's how we can use a capacitor in parallel to do it. Alright, so that's our rectifiers. It's really simple. There are a lot of confusion going on, but this is how it's really simple like this. Now moving forward, we go into a clipper circuit. Now what's a clipper circuit is, it limits the voltage level. That's exactly what the clipper does. It just limits the voltage level in any signal. How does this happen is, if we connect a diode in parallel to the circuit like this. See, this is our, let's say this is our input voltage signal, alternating current, and this is how we get an output. Well, why does this happen is because when it's in the forward bias condition, it will the when the diode is in forward bias condition, it will start passing the current through this, and as we know, whatever the voltage in parallel remains the same. So now whatever the voltage, the forward voltage of this diode is, that will be the maximum voltage of the circuit. We can even adjust this by having another reference voltage source that decides what would be the actual output over here. So let's say our voltage is going from 0 to 10 volts and back to minus 10. The forward voltage of this diode is 7 volts. The output will be maximum 7 volts here. We can now, this happens only on one cycle of the circuit like this. We can do both sides of this cycles by in two methods, which I'm going to show in the next slide, which is like this. Either we have two Zener diodes connected like this, now which means the our output voltage will be decided by the reverse breakdown voltage of one Zener diode and the forward voltage of the other Zener diode. So that's how these Zener diodes work hand in hand to clip both the sides. Or you can connect two diodes in an opposite way like this. Now this set of diode and voltage source will clip our signal in the positive cycle, as we have discussed earlier in the last slide, and this one, just in a similar manner, will clip the negative side. That's all for the clipper. And now heading off to the next topic, which is clamper. Now what is a clamper? A clamper is a circuit which shifts the entire signal either up or down of the reference level, which means uh, like, for example, If this is the signal, it will either shift all of the signal to the positive cycle or above whatever the reference level is, or down the entire signal. It would remain the same. No voltage would be limited or anything done, but the entire signal will be shifted. Now, how does this happen? Is if we connect a diode and a capacitor like this, like a capacitor in series and diode in with a negative on top, right? In this manner. All right. So, but how does this work? Is see when this is a signal when it's in a when it's a positive cycle, your entire voltage goes just forward. It's in the first cycle. Now let's see what happens in the negative cycle. In the negative cycle of the voltage, this diode gets forward biased, means the entire voltage goes down, and that's it. That's how the circuit goes. That's how our power flows, which means that now the output would be zero. But on the other side, our capacitor is getting charged to the peak value. Now when the positive cycle comes back, this diode is now in a reverse bias condition. It won't conduct any current. That means whatever the voltage is, first that would be passed, plus the capacitor will also send in the charge back. That means this was the original value. Now it will increase because of the capacitor is sending the charge as well. Thus our output gets increased. If you want to go to the negative, if you want to shift it down, you just reverse the direction of the diode. That's it. And this can also be adjusted. The level, this reference level, can be adjusted if you connect a biased voltage in the circuit as well. Now our output would be the input voltage plus the voltage charge stored in the capacitor and the bias voltage. So this shift is done as per this shift in signal, extra shift, is because of this bias voltage. See, that's all for today's video. That's it. The clipper, clamper, and the rectifier made simple. I hope this cleared everyone's a lot of doubts, or it made. I hope it made these topics simple. And yeah, if you have any questions, just type it in the comments. Let me know. I would try to simplify it even further, or try to clear out any of your doubts. And see you next time. Right? Thank you.